Now let's see where stacks are used. The same push and pop rule solves real problems that look very different at first. Each of these problems uses the same last in, first out order. The table shows what you push and what a pop answers. First, balance brackets. You push each opening bracket you see. A pop answers, does this closing bracket match the most recent opener? Second, converting infix to postfix. You push operators that are still waiting for their operands. A pop answers which operator applies next. Third, depth first search. You push each vertex you reached but have not fully explored. A pop answers, where do I back up to? Fourth, a function call, which we meet in Chapter 8. You push each call's frame. A pop answers which caller resumes next. Notice the shared pattern. None of these need new code, and none of them are written out here. They all reuse the same push and pop. The table names the pattern, and Lab 2 turns the first row into working C. Now let's use a stack to check brackets. The rule is simple. You read the string from left to right. When you see an opener, you push it. When you see a closer, you first check the stack is not empty, then you pop the top and it must match. The string is balanced only if it ends and the stack is empty. And here is the final test. If the string ends and the stack is empty, the string is balanced. A leftover opener means not balanced. A closer with an empty stack, nothing to pop, also means not balanced. Now let's trace one string, one character at a time. The rows build up as we go. The first character is an open paren. It is an opener, so you push it. The stack now holds one open paren. Next is the letter A. It is not a bracket, so you ignore it. The stack does not change. Next is an open square bracket. It is an opener, so you push it too. Now the stack holds the open paren, then the open square bracket on top. Next is the letter B. It is not a bracket, so you ignore it. The stack does not change. Next is a close square bracket. It is a closer. First you check the stack is not empty. It is not, so you pop the top. The top is the open square bracket and it matches. That is good. The stack goes back to just the open paren. Next is an open curly brace. It is an opener, so you push it. Now the stack holds the open paren, then the open curly brace on top. Next is the letter C. It is not a bracket, so you ignore it. The stack does not change. Next is a close curly brace. It is a closer. The stack is not empty, so you pop the top. The top is the open curly brace and it matches. The stack is back to just the open paren. The last character is a close paren. It is a closer. The stack is not empty, so you pop the top. The top is the open paren and it matches. Now the stack is empty. Now let's trace a string that fails, again one character at a time. Many people think any earlier opener will do. That is wrong. Only the top of the stack counts. The first character is an open paren. It is an opener, so you push it. The stack holds one open paren. Next is an open square bracket. You push it too. Now the stack holds the open paren, then the open square bracket on top. Next is a close paren. It is a closer, so you pop the top. The top is the open square bracket, so the stack now holds just the open paren. But a close paren wants an open paren. The bracket we popped was a square bracket. They do not match. So you reject the string right here and the scan stops. The last character is a close square bracket. You never reach it. The scan already stopped. A close paren does close an open paren, and there is an open paren on the stack, so you may want to search down the stack until you find it. Do not. A closer must match the most recent open bracket, whatever sits on top of the stack right now. Here that is the square bracket, not the paren. So the close paren fails to match at once, and the string is rejected, even though an open paren sits below it.